If a few years from now, summers begin to disappear across Europe, winter temperatures in London drop to minus 20 degrees Celsius, and countries like France and Germany remain buried under snow, the cause will not be war. It will not be a meteor strike. Instead, the reason will be an invisible machine operating deep inside the oceans, a system that silently determines the temperature of the entire planet. This system is called AMOC, short for the Atlantic Meridional Overturning Circulation. The name sounds complex and technical, but its function is surprisingly simple. AMOC is a vast ocean current system that continuously moves warm and cold water along a fixed pathway inside the Atlantic Ocean. This single system explains why Europe is not as cold as it should be, where rainfall occurs across the planet, and why Earth's climate remains balanced. The oceans are not just reservoirs of water. They are active, moving machines, and AMOC is one of the most important components of this planetary engine. To understand how it works, we need to start with a basic fact. The sun does not heat Earth evenly. Regions near the equator receive far more solar energy than the poles. If that heat remained trapped near the equator, those regions would burn while the poles would freeze completely. But this does not happen because the oceans transport heat from one place to another. Near the equator, water in the Atlantic Ocean becomes extremely warm. Warm water is lighter, so it stays near the surface and begins flowing northward toward the North Atlantic. As this warm surface water reaches Europe, it heats the air above it. This is the reason Europe is far warmer than other regions located at the same latitude, such as Canada or Siberia. But this process does not stop there. When this warm water reaches Greenland and the Arctic, the cold environment cools it down. As water cools and becomes saltier, it grows heavier. Heavy water cannot remain at the surface, so it sinks into the deep ocean. This sinking process is the true engine that powers AMOC. The North Atlantic is the region where this sinking is strongest. From here, a deep ocean current is formed, a current that separates from the surface and flows southward through the deep ocean. This deep current is not fast, but it is constant. Over decades and centuries, it spreads cold water, energy, nutrients, and oxygen throughout the world's oceans. This cycle has been running continuously for thousands of years. Warm water flows north at the surface, cold water returns south in the depths. This endless loop is known as the global conveyor belt. As long as this conveyor belt keeps moving, Earth's climate remains stable. If it slows down, weather patterns begin to shift. And if it breaks, the consequences become dangerous. So what does an AMOC collapse actually mean? Collapse does not mean that everything suddenly stops one day. It is not like flipping a switch from on to off. AMOC is not a machine. It is a complex system, and complex systems do not fail suddenly. They weaken silently, step by step. First, the flow slows down. Then the system becomes unstable. Eventually, it reaches a point where it can no longer recover on its own. This moment is known as a tipping point. Once that tipping point is crossed, the system cannot return to its original state. That is the real danger. To understand why AMOC is weakening, we must understand what keeps it running. The answer is simple: cold temperatures and salt. In the North Atlantic, the colder and saltier the water is, the heavier it becomes, and the more easily it sinks. This sinking motion drives the entire circulation. But if the water becomes less salty, even extreme cold will not make it sink. And if water stops sinking, the circulation begins to fail. This is exactly what is happening today. The source of the problem lies in Greenland. For millions of years, Greenland's ice remained frozen and stable. Today, it is melting at an accelerating rate. When this ice melts, it turns into fresh water, and fresh water contains no salt. As massive amounts of fresh water flow into the North Atlantic, they dilute the ocean's salt balance. The water becomes lighter, and lighter water does not sink. This is where AMOC stability begins to break down. This is not speculation or fear-mongering. Scientists have directly measured the increase of fresh water in the North Atlantic. Every year, trillions of tons of ice melt from Greenland into the ocean, and this process is speeding up. AMOC has not stopped, but it is no longer as strong as it once was. According to multiple studies, it may now be in its weakest state in at least the last 1,000 years. It is crucial to understand that Earth's climate does not always change slowly. Sometimes small changes trigger massive consequences. Imagine filling a glass with water. Everything looks fine until one final drop causes it to overflow. AMOC behaves in the same way. As long as it functions, everything appears normal. But once it crosses a tipping point, changes accelerate rapidly. Europe would be affected first, but the story does not end there. The real question is not just whether Europe becomes colder. The real question is what happens to the entire planet when this Atlantic engine weakens. What happens to India's monsoon, to rainfall across Africa, to storms in North America, to the global food system? At that point, AMOC collapse stops being a regional issue and becomes a global crisis. Because when this invisible machine weakens, its impact spreads far beyond a single ocean. And this has happened before. Earth's history records moments when this very system faltered and the planet's climate flipped dramatically. The most famous example is known as the Younger Dryas. Around 12,900 years ago, Earth was gradually warming its way out of an ice age. Temperatures were rising, ice was melting, and conditions were improving. Then something happened that abruptly reversed the process. Within just a few decades, temperatures across Europe and the North Atlantic dropped sharply. Regions that once supported trees and grasslands were suddenly covered by ice again. This cold period lasted for more than 1,000 years. What shocked scientists was not just the cold, but the speed of the change. At first, many researchers doubted that such a massive climate shift could happen so quickly. But evidence began to emerge. Ice cores drilled from Greenland revealed that temperatures fell within decades. Tree rings, lake sediments, and layers on the ocean floor all told the same story. Something had suddenly cooled the North Atlantic. Early theories blamed comets or volcanic eruptions. But as research progressed, one explanation became stronger than all the others. AMOC. At the end of the Ice Age, a massive ice sheet covered much of North America. As it melted, it released enormous volumes of fresh water into the Atlantic Ocean. That fresh water spread across the North Atlantic, just as Greenland's meltwater is doing today. It disrupted the salt balance, made the water lighter, weakened sinking, and slowed the entire circulation. As AMOC slowed, heat from the equator no longer reached Europe. Within decades, the region cooled dramatically. The change was so fast that plants and animals could not adapt. Many species disappeared. Human groups that had begun farming were forced back into hunter-gatherer lifestyles. The Younger Dryas lasted around 1,200 years, and then, just as abruptly as it began, it ended. Fresh water input declined, salt balance returned, AMOC regained strength, and the climate warmed again. But the lesson was clear. Earth's climate does not always change gradually. Some systems flip suddenly once thresholds are crossed. AMOC is one of those systems. Today, we are creating dangerously similar conditions. Greenland's ice is melting faster than ever. Fresh water in the North Atlantic continues to increase. Scientists observe that regions where water once sank quickly now take much longer to sink. AMOC is still operating, but its speed has slowed. Many researchers warn that today's pattern closely resembles the conditions that existed before the Younger Dryas. The difference is that today's world is far more complex. Billions of people depend on a stable climate. Agriculture, cities, power grids, and global food supply chains all rely on predictable weather. If a system like AMOC becomes unstable again, the consequences will not be limited to Europe. Europe would cool significantly, with longer winters and shorter, colder summers. North America could experience rising sea levels along the East Coast as warm water accumulates, along with stronger and more unpredictable storms. Africa and South America would see major shifts in rainfall patterns, leading to floods in some regions and droughts in others. India's monsoon, which depends on interconnected ocean systems, could become erratic, arriving late, falling too intensely, or failing altogether, directly threatening agriculture and food security. AMOC also plays a critical role beneath the surface. It transports oxygen and nutrients into the deep ocean. If circulation slows, some regions could lose oxygen, disrupting marine ecosystems. Fish populations would shift or collapse. Coastal communities that depend on the ocean would feel the impact first. An AMOC collapse does not mean the entire planet becomes uniformly cold. Some regions would cool, others would heat up. The most dangerous outcome would be instability. Weather would become unpredictable, and human civilization is built on predictability. When that stability breaks, environmental problems turn social and political. Migration increases, conflicts rise, resources become sources of tension. Scientists are not saying AMOC will shut down tomorrow, but they are saying the system is weakening and the warning signs are real. Direct measurements, satellite data, ocean circulation patterns, and salinity records all point in the same direction. AMOC is no longer as stable as it once was. Stopping this process completely may not be possible. Ice that has already melted will not refreeze, but the process can be slowed. Reducing greenhouse gas emissions and limiting global warming remain the most powerful tools available. Humans cannot control ocean systems, but they can reduce the damage they cause. And this leads to the most important point of all. AMOC collapse is not science fiction. It is an ongoing process. It does not mean the world will end tomorrow. It means Earth's largest systems are responding to human actions. First, the atmosphere changed. Now the oceans are changing. And when oceans change, they do so slowly, but with enormous consequences. The full impact will not be felt by us alone, but by generations to come. The warning, however, is already here. AMOC is that warning, a reminder that Earth's stability is not automatic. Once balance is lost, restoring it becomes extremely difficult. This is not just Europe's story, it is the story of the entire planet. Because if this invisible machine ever truly stops, we may realize too late that the real power was never fully in our hands.